What I'm going to illustrate today is something that's referred to as special products. Again, the word products implies multiplication. So as we look at this first one, what we're doing is squaring a binomial. And this one has a plus in the middle. And this is the same thing. Squaring a binomial, but this one has a negative in the center. Now, for these, we basically have a recipe. That's why it's referred to as special products. It's sort of a modification of the FOIL, but as we see here, what we're going to do is take our first term and square that. Then we're going to take these two terms, multiply them together. That gives us a positive AB. And then we're going to double it. That is, times it by 2. So this gives us a plus 2AB. And then we square the B, and that gives us a B squared. So repeating it, there's only a little bit of a difference on this other one. We square the first term. That gives us A squared. We multiply these two terms together. That gives us a negative AB. And then times it by 2, or double it. That gives us a negative 2AB. And then we square the last term. That gives us a B plus. So as you look at these, they're very similar. This is called a perfect square. Let me get that right. Trinomial. A perfect square trinomial. And these are always true. Both end terms are perfect squares. And then depending on the sign in the middle, that's the sign you'll have for the middle term here. So let's try an example using this technique. So we square the first term. That gives us 9A squared. We're going to multiply these two terms together. It's going to be a plus. And 2 times 3 is 6AB. Now we're going to times it by 2, or double it. That gives us a 12AB. And then we square the last term. And again, this is a perfect square trinomial. And the thing about perfect square trinomials is that if you recognize it, it will factor into a binomial squared. So that's the first part of our special products. Now, the next special products, again, we're going to use the FOIL somewhat, but it's a little modification. Here we have, again, it's two binomials that we're multiplying, but here it's AB, here it's AB. So the terms are the same, but here's a plus and there's a minus. So we call this the product of the sum and differences of the same terms. And this gives us a special product. That's why it's in this category. Now, another word for these two is that these are conjugates of each other. So a conjugate would have the same terms, but the middle term, one would be plus and the other is negative. And when we multiply conjugates, something special happens. And I'll show it to you as we FOIL. First, will give us an a squared. Outers will give us a negative ab. Inners gives us a positive ab. And then last gives us a negative b squared. Now as we go to collect like terms, we see that these two middle terms cancel out. So our final product is a squared minus b squared. And we call this the difference of perfect squares. So anytime you have perfect squares, this will factor into, I guess I got to bring it all the way up here, into its conjugates. And an example of it would be like 3a plus 2b, 3a minus 2b. So that when we FOIL, we don't have to do our middle terms. We're going to get 9a squared minus 4b squared. The results of multiplying conjugates give us the difference of perfect squares.